Welcome. On behalf of Stack Solution Inc., my name is Olu, and this presentation is all about the Palo Alto Next Generation Firewall VM series that enables us to create a Pan OS server using Azure. And in this particular quick classroom exercise, we're going to be looking at how we test a client server that utilizes Pan OS Firewall to enable its private environment and control firewall rules to initiate different types of protocols within its own network environment, and by that, its own private environment. Now, the very first thing we want to understand is what exactly is the architecture going on over here. Now, the architecture stems from one standpoint, firewall. If we want to prevent different types of networking, application, or transportational network services, Pan OS from a cybersecurity perspective is the key way to go about that. Now, there's a few things going on over here, and if you've been in this full IT training, you pretty much already understand what is going on. Now, if I come right to this perspective, I'm within what we call a Palo Alto virtual machine, which is a web server interface that shows us the access to our firewall environment for our Palo Alto Pan OS system. Over here, if I go to the network, we do see that I have two different firewall endpoints activated, one for an untrust and a trust. These use what we call the Ethernet 1 and Ethernet 2. Never mind about 1/1, 1/2. You want to look at what is going on after the slash. So we have, at least at this point, 7 Ethernet interfaces. Ethernet 1 and Ethernet 2 boils down to our Azure environment where we actually created this Pan OS server, that being this particular virtual machine that has transformed itself to this server system. If I come back over here and I jump into our virtual network, wait for that to load up, I can scoop down to the subnet. Within the subnet, I see varieties of subnet. Over here, my main ball of contention is the private and the public. These two subnets, which are delegations of subnets within a virtual network, have a public IP address range and a private IP address range. From this context, the public IP address range represents our Pan OS Palo Alto Next Generation Firewall's public interface, which is Ethernet Interface 1. The private represents Ethernet Interface 2. And so, this two boils down to this and this. This being the private because it is the trust, and this being the public because it's your trust. So Ethernet 1 over here is your public. Ethernet 2 over here, which is your trust, is your private. Okay? So with that understanding in place, let's jump into some more serious stuff. If I come back over here, I have a client VM that is utilizing our what? Is utilizing our firewall, which is our Pan OS system, which is this virtual machine right here, which is a computer server as well. So what we're going to look at over here is constructing and understanding how we put together a client virtual machine, which in this scenario, actually happens to be a Azure Windows VM, that being this guy right here. So with that understanding, let's jump back to our Pan OS web server and I'm going to be within a network where I can see two activated Ethernets, one for trust, which is public, one for trust, which is private. Now, if I choose to go down to the zone is part of the architecture to put everything alive for our Ethernet interfaces. The virtual routers is also a key component in us architecting our network Ethernet interfaces. Based on the concept of the zone and the virtual routers, if I come back to our interfaces over here, and I simply click on just this one interface, I can see that the configuration is assigned to the untrust virtual router, that being in this location, and the security zone, which is on trust, it, it is based over here in the zones that has on trust and trust zones. And so when we look through all of these other key areas, for those of us who have been in this class, we understand what is exactly going on in there. I'm going to go ahead and cancel that. So how do we begin to perform firewall tests? Well, one of the key things is to understand how to utilize our policies. I'm going to jump into our policies. In here, you can see a lot of architectural concepts. We have a firewall system over here that does an allow for HTTPS. Let's jump into it. When I come into this firewall, I can see that it has a general name called allow HTTPS1. Not a big deal, that is fine. When I jump into the source assigns the zone for the source, which is trust. That being our client that we're trying to use as a private VM to establish connection to the outside world. The outside world becomes what? The destination. When we come to the destination, we assign that as the untrust. For some of us who have already been in this class, we understand what is going on at this point. So our source becomes a private client VM that has a trust private IP, and it reaches out to any destination in the world. Any destination from this perspective, this being an allow HTTPS could be, I want to reach out to CNN or Facebook or Firefox or Wayfair.com, whatever website or whatever application I want to access. And so with the combination of both of those, we have our source being here as a trust. If I want, I can specify a IP address. Now, logically speaking, if you want to put a source address over here, it will be your client's private IP address. But feel free to leave that as any. We come to our destination. The destination is an untrust using our public IP. We come to the application. Over here, I've selected a few websites and applications. Facebook, Facebook's base website, aka Facebook base, Google base, Instagram, and Instagram base. Based on this concept and fact, I am giving an allow on HTTPS for Facebook, Instagram, and Google. It should allow these websites on my private client VM. In this case, we're using Azure as the private client VM. When I come to service category, I can leave this as application default. More importantly, when I come into the actions tab, I want to allow these few websites. Hence, that has been configured as allow. For now, we're going to go ahead and cancel that because all of that looks okay. Based off that configuration, that is why you're seeing all these listed applications. The source being trust, destination being on trust. Followed by that is another configuration called the allow DNS. This is to discipline and dissect every safe HTTPS that has been allowed within our firewall. Now, while this is optional, it's always a good feature and policy to configure within your security space of your PAN OS policies. The allow DNS simply says I want a trust to communicate and be able to respond to an untrust. Be it as it may, every condition stays the same till it gets to the application and it uses DNS. Over here, it also uses application default and it's allowing DNS so that within the realm of any denial of firewall we have, at least for any space or any area we have an allow, let us convert the DNS so that it can what release HTTPS websites. One very important thing is if you are going to deny websites, generally you want to make sure that your allow stays ahead of deny. That means that based off the concept of hierarchy, what you want to allow should be at the top, followed programmatically or manually by allow DNS, and then your deny. That is very, very critical. With all of these three concepts in place and all other things such as when we go to our device and we go to our certificate management, under certificates we have our device certificate over here. That is very, very critical. With that in place, when we come back to the Azure environment, you want to first ensure that you have your Pan OS next generation firewall server set up correctly. You want to pay attention to its connected devices. Over here, at the very least, you should have your ETHO, ETH1, and ETH2. This means the management subnet, public subnet, and private subnet. Now, what is really going on is beyond all of this, once you have your Pan OS server and you have a client server over here as well too that has been created, also utilizing the same virtual network private subnet. In this case, this subnet is the private out of the three subnets under our firewall VNet area. And so a third area comes into play, which is our route table. Because in this case over here, we do have our Pan OS Palo Alto server created via Azure. And it needs a client to consume that firewall. In this case, we are using Microsoft Azure as well too, deploying a Windows Server VM as the client VM. That has been deployed already, and that is what we are looking at over here. So back here in our route table, two things have to be configured to make this whole concept make sense. First is our route. When we jump to our route over here, you need to configure a route that will establish a connection between a generalized address prefix IP address range and where it should jump into, which is regarded as a virtual appliance that points to our next generation firewall Pan OS system. However, in this case over here, we are looking at not just any random IP address, but rather the private designated single private IP address of the firewall that comes from the virtual network associated with it that points to a direct IP address. How do we know this? 172.16.2.4. If I jump back to our Pan OS server and I look at the virtual network associated with it, under the connected devices, I can see that information right here. 16.2.4. 16.2.4. And that is how we carefully allocate and assign the right route on our route table. After that is done, you want to jump into your subnet. You see, within your subnet, you want to ensure that that is also associated with your firewall's private subnet. This firewall virtual network is the same virtual network that also utilizes our what? Our Pan OS server. With all of that in place, if you want to take a look at where this is from, that is simple. We're just coming from there. When I jump back to this perspective and I go to our subnet, I can see that setting right there. It is under this perspective over here. That is the subnet and its IP address range. So now that we understand the concept of the client VM, the firewall PAN-OS server, and our route tables, let's go ahead further to the actual PAN-OS firewall server. If I jump back to our network, I can see that we have two Ethernet active. When we go to the zones, we see the trust and untrust zones that make use of those Ethernet interfaces. Do remember we also have our virtual routers. If I come down to the policies, which is the big player, I can see the allow, and it's supposed to allow this website. Now, it also follows sharply by allow DNS and then by deny all. Do not forget that hierarchy. The next thing I want to do is, because my server is deployed for my PAN-OS, I'm going to go back there. That is my PAN-OS server firewall. I'll come over here. This is my client VM trying to utilize what? My firewall over here. The concept is simple, but one key thing you have to note is that if you go back into this firewall, or rather this virtual network and its private IP address for the client VM, let's select it, and you go down to the connected devices. Amongst this list, you want to target your public Ethernet 1 interface. That is that guy. The public, the untrust, aka the ET1, Ethernet interface 1. I'll select that. You have to make a key step or configuration over here. You have to go to the IP configurations. Within this perspective, you want to select this. Eventually, it's going to create a public IP address for you. You don't know that yet. Provide a name, leave settings as they are, ensure associate public IP address is selected. Under the public IP address, click Create Public IP Address. When you do that, it asks you some key basic questions. Process all of that. When you're done, you'll see something like this. Based off that, you hit the save. As you can see, I don't need to do that. That has been done already from my perspective. I'm going to hit cancel over here. That will generate a new public IP address for you over here with the name that you give it. That is very, very important for it to configure that setting. And so, from the Azure perspective, we have our PAN-OS Linux server for Palo Alto Next Generation Firewall setup. We also have a client Azure VM, which happens to be a Windows server. And then we have our route table configured. Furthermore, we also came into this specific interface to reconfigure and associate with a new public IP address. With all of that in place, and we also ensuring that our policy securities are in place for our firewall, we are good to go with testing. Do remember that based off the concept of this class, there are some other key information and key details you need to set up, such as your NAT gateway or your NAT configuration or policies, whichever you want to describe it as, and then ensuring that under your device, your certificates management has your certificates downloaded and utilized in your client's app. If you're part of this class, you already have the documentation and you can also watch recorded clips on how that is done. Based off that, there are two critical decisions you can make when you are creating your client VM in Azure. You can choose to log in using your basic RDP or log in using Bastion. In this class exercise, we've gone ahead to deploy Azure Bastion. That means I do not need to go back to the client's virtual machine and download an RDP file to log in into. I can simply use Azure Bastion. In this scenario, I've done that already and I've logged in into Azure Bastion over here. a few key things are happening. You see, by the time I go over here to Google, Google is active, Wayfair is not active, Facebook is active, Instagram is active. So some websites are active, some websites are not active. That is the concept of the firewall from Palo Alto next generation firewall Pano system working. It is operating based on our rules. And what were our rules? When I navigate back over here, I can see that I allow HTTPS for these applications. So Facebook, Google, Instagram, anything other than that, which is allowed, those three guys are allowed. Anything other than three of them should not pull up when we log into the client VM. So when I go back to the client VM over here, I can decide to close this. Again, remember, Bastion opens through a website. Hence the reason why we're seeing all that magic. If I go back over here and I click on Microsoft Edge and open it back again, you'll see it can't even load up any information. Should I come in here and I say, you know what, take me to Microsoft.com? It can pull it up. If I come over here, I say go to CNN.com, still can't pull it up. If I go here, I say go to Nike.com. Now pull it up. Now let's think of the other three websites that should go. That is Facebook.com, Instagram.com, and Google.com. Let's take a look at that. Facebook.com. And just like magic, that appears. It's because our Pan OS server that has configured Firewall NGFW has stated that their website, it has a denial on all websites. Above the denial is an allow for specific websites. Facebook being one of them. After all, that is what we're looking at over here. We have our allow. The hierarchy is very important. Allow comes first. If you apply DNS, that comes second, then deny. We can see the applications we're allowing. Facebook, Google, and Instagram. Let's navigate back. Back over here within our client VM. Remember, we're using our client VM to do what? We're using it to point to a firewall, and the firewall is the Pan OS server. Facebook is up. Let's try out Instagram. That should go. Yes. Matter of fact, if I even try google.com, google.com will go through as well too. Load that properly. It's gonna load up. If I go over here, HTTPS. Now we'll pull through. That's our Instagram right there. Got that. Close this one. It's probably struggling a bit. So all of these sites, right? They are pulling up. Our Instagram, our Google, our Facebook, they're all there live and direct. But every other site, they struggle. Nike cannot show, CNN cannot show all of this. Any other website, say we want to try out, let me think randomly, bestbuy.com. It will not show up. So that is really what's going on. I can close that Microsoft Edge and launch it again. You see that? It can't even load the official Microsoft web page. We come over here, we do Facebook, we do websites like Google, shows up. We start to try other websites that are not within the realm of our allowed, which is Facebook, Google, and Instagram. Any other thing will not go through. Let's test it. Click another extra button. We say maybe kind of hard to think of just a random website sometimes, but let's just say walmart.com. And sure, in the same space, if I click an extra open page, I go back again, I say facebook.com, it shows. Say instagram.com, that loads up too. Say google.com, Instagram is a bit stubborn, fully loading up, it takes a few minutes. It shows up. And so that helps us to understand the concept of firewall and how we can deny all websites on a computer server, which is the client server in this perspective, and then begin to decide to allow a few websites. And so that's very, very critical to understanding how Pan OS next generation firewall Palo Alto works. Now, if I look over here at the general concept of what we just looked at, I can see at the heart of everything, we have our Pan OS server system over here. So pretty much what is going on with this diagram is with Azure, we created the Pan OS server that has the next generation firewall with it. Within our Azure environment, that gave birth to this guy, which is our Pan OS server that has been created via Azure. Now, this Pan OS server is using a very critical network security configuration over here. It uses a virtual network that creates three subnets: the management subnet that Pan OS server needs, the public, which is for untrust, and then the private, which is for trust. So it tells us Pan OS uses this virtual network and the subnets to operate. Now, Pan OS being deployed by Azure at the back end has been attached successfully to a Palo Alto firewall, which is a hardware firewall, and they both communicate via Ethernet interfaces. This guy right here is now ready to be used as a firewall to be consumed by any client server. Hence, the reason why this client server is pointing to it, saying I am a client server or VM that can consume Pan OS server as a firewall. As a client, I can be, give me a second over there. As a client, I can be an Azure VM client, an AWS VM client, those are cloud clients, or an on-premise client, which is a data center, a private data center. So, whichever I am, I can be a client that can point to you to utilize you. Should I need to do that in an Azure environment? I would need to ensure that I create my server, which is a client server, utilizing my firewall's what? Virtual network and private subnet. Very, very critical. Should I want, I can turn off my public IP when creating this client VM and my network security group as well. After all, I'm using the virtual network connected to this guy right here, which is our Pan OS. And so, with all things put together, I will be able to perform all of the tasks we just saw ourselves creating. Do bear in mind also too that whenever you're creating this in an Azure environment, as an example, the Pan OS can have its virtual network, and that virtual network can have a bastion deployed. Our bastion gives us the opportunity to log in securely rather into our VMs. In this case, we have two VMs over here, Pan OS and client VM. They are both using the same virtual network. That virtual network has an Azure Bastion deployed. This means that via this virtual network, I can connect through Bastion, through Pan OS VM or client VM. Why? Because both VMs, these two guys, can log in using the same bastion. So that is very, very critical. Hopefully, you digested this information. It made a whole lot of sense, and I look forward to you learning more.